What's up, guys? Today is October 31st, and I'm wanting to go back over some of the complex number stuff we were discussing yesterday and kind of give you a glimpse into what we're going to be covering here very shortly. So I'm going to turn my screen around and let's run through a few things. Okay, so let's go back to the real briefly, to give you an overview. Remember that the whole idea of an imaginary number, it stemmed from when mathematicians were solving quadratics like this right here. You have x squared plus 1 equals 0. So they knew to do this, and they came up to this point right here, and they looked at it and went, whoa, you can't take the square root of a negative number. So they they were they were kind of left in a conundrum. What do we call this? There's no such number as this. So at that time, they just thought they just called it imaginary, very poorly named, but that's just what they call that. So to give a short abbreviation for it, it was I, and I they called the square root of -1. So one thing I want to make sure you realize, this is not a variable. I is actually representing the square root of -1. So don't confuse that. Confuse that like you would, like x up here is a variable, right? That is not. So and we see this the further we go into quadratics and the further we go into polynomials. We see this recur a lot, even and we go on higher and higher and higher into our maths. One thing I do want to point out, in case y'all didn't really pay attention to it the other day, was imaginary numbers. Again, the name's horrible for it, but they're not fake numbers. These numbers actually do have some real applicable uses, particularly in the engineering field, in electronics, especially when you're dealing with AC circuits. They pop up a lot, and they're used to represent certain values. So, but I'm not going to go into that. But just know that this is not totally just pointless. So a few things I want to do with you to start out this morning is I want to show you how to go back over how to simplify like negative radicals. So like, let's start out with something easy. Square root of -36. Whenever I'm working one of these out and I see the negative, now since I've been doing it a long time, I just know it's going to have an I, and I just take the square root of 36. But since y'all are first learning how to do this, I encourage you to literally write it like this right here. Doing this forces you to remember, oh, wait a minute, that's I. So it's going to reduce to an I, or simplify rather. Square root of 36 is 6, so 6I is my 6I is going to be my simplified answer. So there's that. Let's do one that's not quite as easily broken down. There's more to it. So I start out, I say square root of -1 times the square root of 48. Okay, so there's I. And then the square root of 48. Now, guys, you should know, you're in 11th grade, you should know how to find your perfect squares in your head. 4, 9, 16, 25, 36, 49, so on and so on and so on and so on. Use these to figure out which is the biggest one that'll go into 48. It's going to be 16, because the square root of 16 times the square root of 3 will give me 48. So you have 4 radical 3, and you get times that I. And this right here, I'm just going to turn it around. It's going to look like this right here. So that's that is your solving, like simplifying radicals, what that looks like. So the only way to really get good at these guys is just practice, practice, practice. That's the only way. I can sit here and do 100 examples, but the only way you want to get good at it is to do it. Okay, so just go on CUDAsoftware.com. CUDA. Oh, sorry, my computer's been weird. You can check there, and you can find you some good practice materials. And they have answer keys too. So let's take a look at this. So now, in math, now when you took my Algebra 1 class, if I had you for Algebra 1, the first day, well, probably maybe the second day, what I did is I was teaching you how the real numbers are structured. And here's what I mean by that. The real number system, you have your rational numbers, your integers, your natural, and your whole. So, and over here you have your irrationals like pi and the square root of 7, and so on and so forth. And we talked about how rational numbers was any number, basically a fraction like 2/3, 7/9, things like that. An integer was your positive and your negative whole numbers. Okay, natural numbers started at 1 and was 2, 3, 4, 5. And whole numbers were starting at 0, going 1, 2, 3, 4, 5. And up to this point, this is the only system that you know is the real number system. What you were not told, and I didn't tell you this by design, is that even, just as like whole numbers is a subset of natural, integers is a subset of rational, the real number system is actually a subset of the complex numbers. So complex numbers have this form right here, a plus bi, where the a part is going to represent the real part, and this is going to be the imaginary part. Okay, real part and imaginary part. So, you've been doing complex numbers all along. You just was not aware of it. So, to give you an idea how I can explain, how I can make sense out of that, when you were learning, your basic numbers like 5, there's a 5 there. What was really there and you wasn't aware of it was it was saying 5 plus 0. Well, 0 times anything is 0, right? So you didn't need to know this. This right here was not necessary to know. You just knew the number 5. Now we're expanding your understanding of numbers. That every number is actually a complex number, but if we're just talking about 1, 2, 3, 4, 5, 2/5, 7/9, 3/8, it just has a 0 as the imaginary part, because it is a real number. So, wanted to bring that to light to you. So now let's go through and let's do one or two simplifying complex numbers problems. So let's see. Let's start with something easy. 2 plus 3i minus 5 minus 6i. So these right here, they're just like a normal algebra problem. So there's a minus sign in between them. So remember, you have to distribute that negative, and it changes the signs in here. So you got negative 5 plus 6i. I can just bring this down. So I have 2 minus 5, which is negative 3. 3i plus 6i is 9i. That's it. Right now, just simplifying complex numbers. That's all there is to that. Let's take a look at one where you're foiling. So if you have, well, heck, I'll use the same ones. I'll just use multiplication this time. So I'm going to take in FOIL, so that's 2 times 5 is 10, negative 12i, 15i, and negative 18i squared. So now you look at this and you go, well, okay, I see, because you see the i's and you associate it with x, but don't forget it's not a variable. But you look at that and you say, oh, okay, so we got 10, and that's a difference of 3, so that's going to be 3i. Now here's where you got to be careful. You'd be tempted to leave this like this. Now, for a second, let me go like on a slight rabbit trail, but I'm not going to go far. I'm going to come right back. The I squared. Remember back up here when it said I was the square root of negative 1? Well, if I do that inverse operation, if I square both sides, that's going to cancel out this square root and the square. They're going to cancel. That gives me a negative 1. So I squared is actually negative 1. Okay? So watch what's happening here. So I'm back down here now. I squared is really representing negative 1, so that means that is multiplied by negative 1. So that's going to be a positive 18. Is that 3i and that 10? Well, look here. 10 plus 18, 28, plus 3i. Now it is simplified. Okay. Now, so one other thing I didn't talk about yesterday, but I'm gonna go ahead and put it on my video, and those who are smart enough to check out my videos, you're gonna be ahead of the game. And what I want to show you is this: is that in the higher you go in math, it's handy to know how to graph a complex number. So now this looks a lot like your normal plane, and as far as the semantics of how we graph on it, it is. But let me go on a little side note for a minute. Now this right here is called an Argand plane. I learned that from watching some lecture videos and all that. It actually had its own name. I just called it a complex number plane. That's just what I called it. But it's actually called an Argand plane, just like the regular grid that plane we work with is called a Cartesian, because of Rene Descartes. This was made by a man named his last name is Argand. I just can't remember the first name. All right, but let me explain kind of what they're doing right here, so that you understand why am I calling it imaginary. So going back to the history lesson from yesterday. Remember how we talked about our understanding of numbers expanded as technology and society advanced. We started having to understand fractions and all that stuff. So in this number line is our real number line. Okay, that's what that is. So there's nowhere on this number line to be able to illustrate a square root of negative 1, because the square root of negative 1 is not as they call it, not a real number. So they looked at it and went, well, we got this number now that we know about. Where the heck are we going to put it? Well, so what Mr. Argand here did, he said, okay, this axis right here, this number line we have, we're going to call it the real axis, and we're going to make a y-axis, and we're going to call this the imaginary axis. So that's where this is coming from. So the real axis is every real number you can conceive. The imaginary axis is going to be all the the imaginary parts. Now here, this is actually a really, as far as the application, is a really simple concept. So you know how like on a regular Cartesian plane, you have an x and a y coordinate, and you say, okay, if if I said graph the point 1, 2, go right 1 up 2, and voila, there you are. Well, works just like that with a complex number. So if I have 2 plus 3i, this is going to be the real number, right? This is going to be the imaginary number. So you can think of this like an ordered pair. You don't necessarily have to put I put the I there just for effect. So let me show you what that looks like. So you got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so you got 2, and then you go up 1, 2, 3 on the I. See, this is the I axis. So this is the point 2, 3i. Now I'll do a couple more with you. Let's say you had -1 plus 5i. Okay, so that's the x one, that's the y one. So go back here, -1. 1, 2, 3, 4, 5. So -1, 5, and I. That's how you graph on a complex number plane. So what's your takeaway from this? Your complex number, the real part is the x part, the imaginary part is the y coordinate, and you just plot them like a normal coordinate. So let me. There I am. I hope these were beneficial to you to kind of get you going. The further we go into this, now I will actually be teaching in class the Argand plane and all that. I just do that as like a little preview for those who happen to be watching. Well, actually, so once we get this complex number stuff down, we feel a little bit stronger. I'm going to branch it back over into the quadratic functions. Remember, I said I was taking kind of like a little rabbit trail off the quadratic functions for a second to kind of solidify this, and then I'm gonna come back and show y'all out. So happy studying. Have a great and a safe Halloween day. Don't eat too much candy. I would hate for you to throw up in my class. So y'all have a great day. Bye bye.